Understand integration by parts in just 4 minutes. The integration by parts is used when we are trying to integrate an expression whose factors are different types of functions. For example, in this expression, we have 2x which is an algebra, and sin x which is a trigonometry. In this expression, we have an algebraic and an exponential function. And for this, we have an exponential and a trigonometric function. In these situations, we have 2 different types of functions and it cannot be solved by using substitution method. Therefore, we have to use integration by parts, and here is the formula of it. In case you are wondering how the formula is derived, I'll be briefly explaining it. Otherwise, you can directly skip to the following parts of this video. Remember the formula of the product rule? The formula of integration by parts is just basically the reverse of it. As you can see, we take the antiderivative, or integral, of the product rule formula. For the left-hand side, notice that we have both integral and derivative, so in the end we left with uv. And for the right-hand side, notice that we can actually cancel out the dx. Therefore, we only left with the integral of u dv, plus the integral of v du. We swap the position, and bring the integral of v du to the other side. That's how we derive the formula of integration by parts from the formula of the product rule. Notice that the integral of the function that we wanted to integrate consists of u and dv, meaning that we let part of the function equals to u and dv before we perform integration on it. But how do we know whether which part of the function is equal to u or dv? For the selection of u, just remember the acronym, LIATE, where L for logarithmic function, such as the natural log of x. I for inverse trigonometric function, such as inverse of sin x. A for algebraic function, such as x or 2x squared. T for trigonometric function, such as cosine x. And lastly, E for exponential function, such as e raised to the power of x or 2 raised to the power of x. We choose part of the function equals to u by using this order. As an example, for this function we have 2x, which is an algebraic function, and sin x, which is a trigonometric function. Notice that algebraic function has a higher order compared to trigonometric, so we choose 2x as the part of the function that equals to u. After we have chosen the u, the remaining part of the function becomes dv, including the dx. Then, we differentiate the u so that we will be getting du in terms of dx. And for dv, we integrate it, and we will be getting v. This step is crucial so that we can plug in the terms into the formula of integration by parts. Now, let us solve for this example. The first step is to choose part of the function to be u and dv, just like what we have done previously. For the u, we take the derivative of it, and we will be getting 2. Bring dx to the other side so that we have du in terms of dx. And for the dv, we take integral on both sides. For integral of dv, you can think it as the integral of 1 dv, so we will be getting v. Integrate sin x, and we get negative cosine x. Now, we have all the terms and we can plug them into the formula accordingly. For u we have 2x, and dv we have sin x dx. Notice that this is exactly the same as the initial function that we wanted to integrate. For the u and v, we have 2x and negative cosine x. And lastly for the v and du, we have negative cosine x and 2 dx. All we're going to do now is to take the integral of this part. Notice that we have a constant which is the negative 2, we can bring the constant to the outside of the integral. Here we have minus and negative 2 in brackets, so we get positive. Integrate cosine x, we get sin x. Therefore, we have negative 2x cosine x, plus 2 sin x. And we are done. But remember, don't forget to add plus c after we have finished integrating, and we got our final answer. I spent hours making videos explaining math topics, and all I ask for in return is simply to like and subscribe. Thanks for watching, see you in the next video.